I'm going to talk about CQRS and Event Sourcing a bit in more detail than I did this morning, and it will involve some live coding. And I'm going to ask you to be with me on that, because every time I do that, every practice session is like perfect, you know that. And when you do that on stage, things happen, right? So if you see something, say something, right? Thanks. I am going to start with a small confession. Well, small, it's a pretty big confession, actually. I have created some really, really ugly software in the past. It's horrible. And I feel extremely sorry for the people that have to maintain that software these days. And if it's you, I'm sorry, I'll buy you a beer. The architectural pattern that it followed looks more or less like this, right? The layered architecture. It's a beautiful architectural principle that really helped us in the 70s and 80s. Strange enough, it is still a dominant architectural style today, right? And not just for legacy, but we see the same thing in a lot of greenfield applications. And I'm not saying this is a bad architecture. I'm just saying this is a bad default in the type of software that we need to build today. I'm going to zoom into the domain model a bit here. So let's imagine we have an application, and the domain model is sort of at the foundation of it, right? Probably we have a relational model in our database that is hopefully a one-to-one mapping, so that Hibernate and all that cool stuff can help us get some data out of that database. And then there's a service layer that contains these services, and initially, in a greenfield situation, everything maps really nicely, right? There's this really nice order service and inventory service and everything, and then there's a bit of logic, sometimes in the domain model, sometimes in the service layer, sometimes I don't know where, nowhere. And then the next service also maps quite nicely to one of these entities. And then there's that service that maps to everything. And this is a very typical thing in all of the projects that I've been involved with that architectural style. That was a long time ago. I quit doing that. And as a side effect, you get these really nice SQL queries. And this is a real one. This is a query somebody actually gave me. So I used to do this to present about this, and I had one of my own projects, SQL queries, that I thought was pretty obnoxious. But somebody said, I've got a better one, but you have to promise me that they cannot read what's in the query. So I thought, who cares, projectors, they have, was it 1024 by 7 something pixels? So that leaves about 4 pixels per character. Nobody can read it. And then suddenly I was doing a presentation somewhere, and they had this really high definition projector, and I thought, oh, people can read the characters. And then I started to read the characters. I could still not read the query. So to give you a small summary, this query has 22 joins and 6 subqueries. They are looking for somebody. They're hiring. Just in case, right? Give me your contact details. I've got an awesome job for you. You can do this 24/7, optimizing this query, right? All right. So what do we do? This doesn't perform, obviously. So what do? We solve that performance problem. And of course, this is a rather exaggerated view of reality. But the thing is here, if you look at the solutions, quote unquote, to this problem, and their locations. They're in the user interface, they're in the service layer, and they're in the data access layer. They mostly involve caches, right? Caches are not problem solvers. If you have a performance problem, the cache is not going to solve that performance problem. If you have a well-performing application, a cache can improve that. But if you look at this, the problem really is in the domain model. And all the solutions are in the other places. So even though we think we're building this high performance, I mean, this is the feeling you have when you start every project, right? You're going to do, this time we're doing it right. And this could be a greenfield project or a refactoring that you're planning to do. You've got this in mind. But you end up with this. This has all the characteristics of a high-performance application, except for one little thing. And that's the thing we don't see. Right. But I'm pretty sure this will not go as fast through corners as the other car we just saw. Now, I like analogies, but let's go back to software, right? There's a term for software where the domain model is sort of causing all sorts of trouble all over in our application, and it's called the big ball of mud. Now here's news for you. It is not mud. And here's the architect proudly protecting its creation. Right? Now does the term code smell start to make sense to you? Okay. So of course, the big ball of mud is problematic because the only thing we can really do to it is add more mud, right? There's all sense of structure inside is lost. It's just a big gooey mass, right? And if you realize, or if you think about it, in a lot of legacy code, the only thing it can really change is add new stuff to it, because understanding what's inside is, well, it's nearly impossible. So, as I said, I created ugly software, and I've made all these mistakes, unfortunately, more than once. I always say I don't mind making mistakes. Making mistakes is cool, because it gives you a learning experience. But making the same mistake twice, that's not cool, because it means you failed to learn, right? So I saw this pattern in a lot of projects that I was involved in, and I decided to do something about it. And I started an experiment. And, well, if you put your code on GitHub, or at the time it was even Google Code, you need a name for it. Well, Axon Framework was not the original name. It did not have the term framework in it, because it was an experiment. And I got an email from a company in France saying, hey, we thought you would like to know that we are using your framework in production. That was 2 news items in a single sentence. Oh, is it a framework? And, uh-oh, production. But, there's production and there's production, right? I mean, sometimes you have an Excel sheet and 2 people need to work on it, so you've got something in production. So I thought, oh, cool, yeah, what do you use it for? Well, it's a tool that we use, so I thought, Excel sheet. It's a tool that we use to track tools used in surgery. Ooh. That scared well. As far as I know, nobody has died because of complications caused by whatever they call the framework. But that did give me the confidence that I could use this myself in projects, maybe. We called it Axon Framework somewhat later and started using it. This was around 9 years ago, right? So Axon has been around for a while, and it was a great learning experience to do this on an open source project. Now the thing that Axon does, oops, that's a bit too enthusiastic. The thing that it does is it forces you, or stimulates you, so to say, to split the command component from the query component. Right? The command component is responsible for handling commands which are intents to change the application state. And quite typically, it involves business logic to make decisions. Is this a legal state change? Is this a legal thing to do? And if so, what are the side effects of this change? On the other side, we have the query side, and that is responsible for handling requests for state. You have to expose the state of your application in some way, and in many applications, in more ways than one. Right? And now what we can do is we can create models that focus on the specific task that they need to do. So we get more but smaller models that are focused on that specific task and thus easier to build and maintain. But it would be nice somehow, if you make a change, to see those projections reflect that change, right? And we can use events for that, right? We see events everywhere. I mean, the term event-driven microservices, and I know I said it this morning myself, but it appeared a lot of times during this conference. And events are a very valuable component in our applications. So essentially, the command model emits events to explain or to tell the rest of the components what decisions it had made. Right. Now, we can accommodate in, different non-functional requirements in these models. Right? We can decide, oh, if there's a specific part of the model that needs to handle high throughput at low latency, we'll put a different effort in that model as one that has a very low throughput and where we don't really care if we even get a response, right? So putting all of that in a single model is going to be problematic because it's going to be very hard to isolate some of these components and optimize, right? As I said, there's something special about these events. Events retain value. So most of the messages like commands and query, a query loses value as soon as you get the response. A command loses value as soon as it triggered side effects. But events describe something that happened. And I'm talking about domain events here. So we can store these events and capture them, and then later on we can do analysis. We can find out what happened. A lot of our customers use this for support. Right? A customer calls, I don't understand why the application is behaving like this or that. Well, let's check. They look at the event source, and they see everything that happened. Ah, it's because you pressed that specific button, or you closed something, and therefore, etc. And it's remarkable how humans tend to forget their mistakes, but as soon as you remind them, they'll understand and know. But just emitting and storing these events is not enough. That is not event sourcing. That is maybe an event-driven application or an event-driven architecture. Event sourcing is using those events as your sole source of truth. The only state you have is the events. And maybe some other state temporarily stored, derived from those events for performance reasons, right? So imagine we use state storage, and we have an order, and it has an identifier and it has a certain state. So the only thing we can now see is that somebody bought a nice chair and returned it. That's the only thing we have. If we had event-sourced that order instead, we would store everything that happened to that order over time. And now we can see it was created, 2 chairs were added, 1 was removed, the order was confirmed, it was then shipped, and then the user canceled his order and sent the chair back. Now, I'm not a retail expert, but this might be a sign of a certain pattern, right? There might be something about people adding a lot of items to their shopping cart and then reducing it to 1 and then ordering. That might give you an indication that, hey, maybe that person doesn't know if he really likes that chair. He wants to see it in real life. Not sure what you can do about it, but that's not my problem. Now, the whole Axon way of developing software has led us to see that monoliths aren't really a bad thing. Right? Sometimes, especially in the context of microservices, monoliths are like, ooh, they're the devil. Do not build a monolith. You will regret it. But a monolith is not really a bad thing. The big ball of mud is a bad thing. And the problem is many monoliths tend to evolve into a big ball of mud because of how we maintain it. But a monolith in itself is not bad. I mean, yes, it's heavy. It's probably harder to deploy. But at least it doesn't smell. There was a very interesting observation by Martin Fowler that almost all of the successful microservices stories started with a monolith that was then taken apart and deployed as microservices. Whereas most of the unsuccessful stories started with a from-scratch approach to microservices. And that's because microservices are really hard. And they're not only hard because of technology, right? We need to have a certain level of maturity in our organization to be able to deal with microservices. But it's also a question of where do you cut the functionality? Which functionality belongs to one microservice and which one belongs to another? A friend of mine has a very nice approach to microservices, and he calls it a noun-driven design. It's very easy. You take your specification document, and every noun you see is a service. And of course, that's something you do not do. Unfortunately, it is done a lot. And if you look at those failing projects, that is often what happens. We end up with order service, inventory service, customer service, et cetera, et cetera. Oh, everything related to an order goes to that. Yeah, but what if we ship an order? We've got shipment service and order service. Oh, well, 50-50. We roll the dice and we'll see. So you end up with basically a distributed monolith. So we believe in an evolutionary approach where instead of going directly to microservices and probably ending up with a distributed big ball of mud deployment, we suggest a slightly different route. Build yourself a structured monolith, evolve that into microservices by extracting components. And as you move along, you can extract more and more, and maybe even go serverless all the way. Right? Not caring how many instances you have running at all. And we achieve that by location transparency. And in Axon, there's 3 places where that location transparency is sort of safeguarded, right? It's because of explicit messaging between components. We use the command bus, query bus, and event bus to dispatch the command queries and event messages between components. That allows us to basically build an Axon-based application, scale it out, and now we need to have something in between. And last week we announced the Axon Server, which we are going to open source very soon. There's a bit of work involved in that, which sits in between, and it doesn't only transport messages, but it can also store these events for you for later use. And that allows us to very dynamically evolve the application and even scale if we want to. But I can talk about it, but I can also show it. Now, we only have a few minutes left, so bear with me. This has to be easy, otherwise I'm not going to make it. So let's have a look at the application here. Can you read this in the back? Kind of. OK, I'll switch to presentation mode in a second. So here's my bike aggregate. So an aggregate is a consistent unit in the command model, right? It makes sure that all the decisions made by this bike, they are atomic decisions. All the state changes are atomic in this part. Now there's a little to-do here. And let's do that. Let's implement the rent bike command handler. Oops. Rent bike command. Now in Axon, the only thing you need to do for a command handler is create a method that accepts the type of message you want to handle, annotate it with @command-handler, and there you go. Now, we need to make a decision. OK, we're going to rent this bike. The aggregate represents a single bike that we can rent out and then return. We need to make sure that the bike is available for rent, otherwise we cannot rent it out. So I'm going to add a little assertion. This is just the Spring assert. We assert that it's available, and we say cannot rent out our bike already rented out. Something like that. So we check the current state. Right? That is the decision we need to make. And now the next step is, OK, we need to decide on the side effects. What is the side effect of this method? Well, the side effect is that the bike was rented out. Right? So in Axon, we do apply new bike rented event. And we mention the bike that was rented out. Now this apply method makes sure that the event sourcing handlers are invoked. And this is very important. When using event sourcing, you need to split the decision making from the state changes, right? Because the only thing we have are the decisions that we have made in the past, and we do not want to validate those decisions. If rules change, well, too bad, it happened in the past, right? So better act accordingly. So when a bike is rented out, we say it's not available. When the bike is returned, it is available again. I do have another to do. Now, when that event is published, we need to update our view model. And I have an extremely complex database implementation here called a concurrent hash map. And it does work. It doesn't really scale, but yeah. So I'm going to create an event handler for the bike provisioned event. And so as soon as a bike is provisioned, I'm going to add it to our database. And there's a very nice SQL language called put. And we add a new bike status. Event.getBikeID, event.getLocation, and it is available for rent. All right. Now, what can possibly go wrong if we just run this? Okay, what's wrong here? Let's run this application and see what happens. Ah, I love it. Just put it there if you know it's wrong. All right. Let's see what happens. Can I? So I've got my some Postman. Oh dear, where's my? Let's provision a bike. So let's provision a bike in Washington D.C. And as soon as I do that, I get a UUID, and then I can rent out the bike by doing an empty post request to that URL. Status 200. And if I now do a bike overview, I should be able to see that we have a bike that is not available in Washington, D.C., right? Because we've rented it out. Now, this view model, one of the things Axon allows you to do is create subscription queries. And it allows you to stay up to date on the state of your request. So I can now take this, and now we see here, there is I'll try to enlargen it. There is a bike in Washington not available, so let's return that bike. Let's return the bike. And we're returning it in Chicago. I hope this is not a bicycle, because that's a hell of a ride. Here we go, it's 200, and here we go, there's an update here. So we can get automatic updates, right? So that's a type of query that we call subscription query, and it's sort of keep me up to date on the state of some object. And you get to decide what the domain model you want to use for the initial result, the current state, as well as every update you want to send later. Now this is really nice, but this is a monolith, right? So let's stop this application, and let's make this, I'm going to switch to normal view if you don't mind. Let's move this to another module. So I've created a few empty Spring Boot applications. And I'm going to, why don't we scale out all the way right away and create a query component as well. All right, so now we start the bike rental application. And if I start sending commands, it's going to fail because there's no command handler anymore. My bike aggregate, all the command handler methods that we have, they're gone. So I'll start that one up and start the query component as well. Come on. All right, so let's provision another bike in New York. And as you can see, it still works, right? We've moved, so I'm doing my request still to the original application, but my command handler is now somewhere else. And I've got Axon Server running in the background, and it knows about these applications. It knows that, hey, there's a command handler there. So if that command is being sent, I need to send it to that specific instance because it told me I've got that command handler. And we can still rent out the bike. Whoops. Right, that works, and we can return it. So where shall we return it? There we go. Where all bikes end up eventually, I guess. So this still works. So we've scaled our application. We've created these microservices, and they're truly micro because there's two classes, one Spring Boot class and one Axon class in them, and that's all we need. And we can see this in Axon Server. We can see an overview of all the components that are running. So we can see we have the bike rental application, one instance of the command application, one instance of the query application. We can click on them and see some details. So here we can see the types of commands that this specific instance accepts. So if we want to, we can copy the bike class even into the other class and launch them, or sorry, the bike class into the main application, and it doesn't matter. It doesn't matter if your services don't have to be homogeneous. You can have these command handling components everywhere you like. That gives you very dynamic scalability and allows you to evolve into the microservices architecture that you would like to have. That's about all the time I've been given for this session. If you have any questions, I hope we can take one or two now. The gentleman close to the camera. Yeah.
You talked about location transparency. Could you elaborate a little bit on that?
Yeah. So can I elaborate on location transparency? So essentially, in location transparency, what we mean by that is the fact the two components that communicate should not care about their respective locations. It shouldn't matter whether they're in the same deployable unit or if they are in different VMs or different machines, different data centers, different planets. Well, theoretically, it should not matter, right? Of course, it does matter in the sense of you need to transport the message from A to B, but that is non-functional, right? For the code you write, it should not matter where these components are deployed.
Is there anything in the framework that handles versioning of events?
Yeah, so is there anything in the framework that handles versioning of events? Yes. So the serialization of these events will attach we call it revision, because version is always a bit annoying to use because of other contexts. So we call it revisions. And you can, if you store the events especially, I mean, just imagine if you look at code you wrote half a year ago, you have this slight feeling of embarrassment, right? Imagine seeing and having to deal with an event you wrote 5 years ago. So there's a concept of upcasters that you can build to translate the old representation or serialized form of an event into its current form. So yes, there's lots of mechanisms to help you with that. One more question.
So, I mean, if you look at a typical domain model in an organization, so, I mean, if we start to, build services for each domain, and you talked about a distributed monolith, right? How do you take that distributed monolith and try to break them down into further down into smaller components or smaller microservices based on domain bounded context?
Yeah. So the question is, if you have a domain and instead of having to go to this distributed big ball of mud, how do you separate? How do you go on separating them? And you mentioned the term bounded context. That's a very important one, because a bounded context is setting the area in which a certain model has value. And it's important to describe the exact purpose of a model. So there should not be one model for the entire domain. So the canonical domain model, if you ever built one, run now. That's fine, I did it, so it's okay. They're good for humans to discuss a domain and to get an understanding. They're horrible for computers. So you want to be focused and more on business processes. That should be your focus. Usually the business is already organized around ways of doing business. So we should organize the software in the same way. That is a short version of a very long answer otherwise, so you can stick around if you want to. Last question in the back, I hope. Yeah. Yeah, so the Axon has support for sagas. Basically, a saga is a stateful event handler that allows you to drive a process, right? So you can listen to events of different components and react accordingly and organize a process of some sort. Some sort of eventually consistent transaction. Base transactions are typically implemented using sagas. So yes, there is saga support. I guess that's all the time we have. I thank you very much and enjoy the rest of the conference.